How would you summarize those core beliefs? What is it that you believe about the way computers should work and what they can do for us that keeps you not only coming through that decade, but also doing what you're doing now, making bets I'm sure you're making for the next few decades?
The first core belief was our first discussion was about accelerated computing, parallel computing versus general purpose computing. We would add two of those processors together and we would do accelerated computing. And I continue to believe that today. The second was the recognition that these deep learning networks, these DNNs that came to the public during 2012, these deep neural networks have the ability to learn patterns and relationships from a whole bunch of different types of data, and that it can learn more and more nuanced features if it could be larger and larger. And it's easier to make them larger and larger, to make them deeper and deeper, or wider and wider. And so the scalability of the architecture is empirically true. The fact that model size and the data size being larger and larger, you can learn more knowledge is also true, empirically true. And so if that's the case, you could, what are the limits? There's not, unless there's a physical limit or an architectural limit or a mathematical limit, and it was never found. And so we believe that you could scale it. Then the only other question is, what can you learn from data? What can you learn from experience? Data is basically digital versions of human experience. And so what can you learn? You obviously can learn object recognition from images. You can learn speech from just listening to sound. You can learn even languages and vocabulary and syntax and grammar, and all just by studying a whole bunch of letters and words. So we've now demonstrated that AI or deep learning has the ability to learn almost any modality of data, and it can translate to any modality of data. And so what does that mean? You can go from text to text, right? Summarize a paragraph. You can go from text to text, translate from language to language. You can go from text to images. That's image generation. You can go from images to text. That's captioning. You can even go from amino acid sequences to protein structures. In the future, you'll go from protein to words. What does this protein do? Or give me an example of a protein that has these properties, identifying a drug target. And so you could just see that all of these problems are around the corner to be solved. You can go from words to video. Why can't you go from words to action tokens for a robot? Mm-hmm. From the computer's perspective, how is it any different? And so it opened up this universe of opportunities and universe of problems that we can go solve. And that gets us quite excited.